Hello and welcome to Ask the Expert. My name is Christopher and I'm fortunate enough to have Christopher with me. And Christopher, do you mind telling us a little bit about yourself?
Of course. I work as an acoustic engineer at Dynaudio, and my job is to tune the speakers from concept to final product.
So it's a long journey, right?
It's a long journey with a lot of people.
I know we are at we're in high end right now, so it's a little bit loud, but should we do a question?
Yeah, let's do that.
Christopher, what would you use for room treatment that doesn't look like it's from a sound studio?
That's a difficult one to answer actually, because there's a reason why the material looks like it does.
Yes.
Especially because I know the user asked, especially for the low frequency part of the room treatment, and this is it's a tricky one to deal with.
Okay.
You want something that when we deal with these the low frequency room modes in the room, we need to treat it in what's called the pressure domain.
Okay.
And in order to do this, we need something that is big and it acts like an absorber.
Okay. And something big wasn't exactly what they were looking for, right?
No.
It's not nice to have in your living room.
No. The good thing about it is that you can put it against the wall and you can put it in the corner.
Okay.
So you don't have to put it in the middle of the room.
So there are things that you can try to hide away, but it still look big.
It will always look big because you are dealing with large wavelengths, low frequencies, a large wavelength, and you need something that can act slowly. And in order to act slowly, it needs to be big and slow. But what you could do, so it doesn't look like a studio, is actually to build a new wall.
A new wall.
A new wall. So if you have this is your back wall, and this is the problem area.
Yeah.
You can put like a plasterboard in front of it.
Okay.
For instance, like 10 centimeters, 30
Yeah.
centimeters in front of it, and suspend it so it's not hard stuck to the wall.
No.
So it kind of acts like a big membrane.
Yeah. So there's some room in
There's
between the
exactly.
two.
Then you can put some damping material in it, and you have the air, and then this plasterboard actually absorbs the low frequency energy as it kind of reflects on the back wall.
And you said was it 10 centimeters out or something like that?
It depends on how low in frequency you would like to act, and also the size of the plasterboard.
Okay.
But if you make it, the bigger the better.
The bigger the better.
The bigger the better. But at least it doesn't look like you have put something up, because you can kind of you can paint it like the wall, and it looks like
So it creates a space that helps to absorb all of the
low frequency energy. Exactly.
Right.
That's one way to do it. So if you want to use a plant as
you said,
as suggested by the in question, then you need something that is big and something that acts like a panel absorber, something that can actually move. So maybe some weird cactus can do it, I don't know.
But that's a guess, right?
That's a guess.
Yeah.
And probably not something you would have in your corner anyway.
Okay, perfect.
Yeah.
Christopher, the next question is about subwoofers, and more specifically, how do you decide if a subwoofer is good?
Yeah. Actually, it's quite easy.
Yeah.
If you know what you're looking for.
Okay.
So you actually judge it the same way you would judge a normal loudspeaker. But it's easy to judge a normal loudspeaker because you have the low frequency, you have some mid-range, and you have the high frequency. So you have like the full picture to decide upon if it's good or not. If you listen to the subwoofer alone, you only have like the sub part, and it can be tricky for the normal user to know if this is a good sub. Does it actually perform as I expect? So what I would do is to have a sub and have a small two-way system.
Okay.
So we have like the full system, and then you listen for the space in the music, and you listen for the stereo image and the depth and so on, and then you turn the subwoofer on and you turn it off.
So you switch around.
You switch around, and if the subwoofer adds extra space around the instruments, or it makes the recorded space sound more natural, in your opinion, then the subwoofer is probably working quite good.
It does what it does.
It does what it does, but in a correct way. If the space around the instruments and the recording becomes boomy and all you hear is the subwoofer, then either the subwoofer is way too high or it's not working as it should.
Is there any reason that you would use a two-way loudspeaker?
No, it's just to have something that is small, actually, and that doesn't play too much bass.
So you could also do it with a three-way?
You could also do it with the bigger speaker.
Perfect.
Yeah.
how do you tune a speaker?
That's a good question and a long one. First of all, it takes a long time to probably tune a speaker. At the audio, we have a big measurement room, and that's where everything begins.
The new Dynaudio Labs, right?
Exactly.
Yeah.
So when we have a box, a cabinet, and we have it can be a prototype box, a square box, whatever, and we have chosen some drivers that fit the box, then we take the box and the drivers, mount the drivers in the box, and take it in the lab, and then we measure the response of each driver individually, without any filters, without anything. It's because then we have the complete, called the system response, measured around the entire speaker of each driver, and then we can start to tune the loudspeaker afterwards.
Okay.
And this is the basic starting point, even though if it's a passive or an active speaker.
So we do this every single time?
Every single time, and every time we change something on the cabinet, as we progress the cabinet or the drivers, then we redo the measurements.
Okay.
Because everything has an effect on the acoustics.
Exactly.
Exactly.
And I guess so, when you have these measurements, you can see, I'm guessing now, there's a dip or something when it goes way too high.
Exactly.
Then you put in something new and you take out and you change and...
Not yet.
Not yet?
Not
Okay.
yet. But we start to analyze all the results in the frequency and the time domain. And then we start to simulate the filters. Let me take an active system, because that's the easiest one, kind of. Then we take all the measurements, we put them in MATLAB, where we have built some simulation tools that can help us to analyze how does the different filters affect the system response. And then we can simulate, and we can try it afterwards, and we can listen. Every time we simulate something and build a filter, we put it in the speaker and we give it a listen. Does it listen as we expect from the simulations?
Okay. So you simulate, you get a filter, you put it into...
We put it in and then we listen.
Okay.
And then we also redo some of the measurements just to confirm that our simulations are correct.
Okay.
And then we can say, okay, this is how far we got with this filter. Now it sounds like this. Let's try something. There's always an issue. There's always something you can tweak and play with. And then we go back to the simulation, redo the tweaking, fit it in the cabinet, listen, measure, and so on and so on and so on.
It sounds like it's a process that goes on for a long time.
It's a long process, and it's an iterative process. And you always revert. And every time you do a change mechanically to the cabinet or the drivers, it's from scratch again.
Okay.
And it's the same when we do passive speakers. But here we don't simulate as much.
No.
So we measure, we look at the responses, and then we sit down with a piece of paper and start actually calculating how to put where to put the filters, and then we build the filters physically because it's a passive system, so we have to build it. And then we build the filter, we redo some of the measurements again, and we start to listen.
And you start to listen.
Yeah. There's always a lot of listening involved, and it's kind of the same approach.
So when do you know when you're done? Are you ever done?
No, we're probably not ever done. There's always something you would like to change, just slightly. But at some point you say, okay, this is the final cabinet. It performs well. These are the final drivers. They perform well. This is the final filter. It really performs well. Yeah. And this is, at some point you have to draw
the line and say this is a good speaker.
This is actually a good speaker. It performs as expected in these criteria we have for tonal character, balance, imaging, depth, and so on.
Okay. And I remember that there was another question that was related to it. Do you try to do this in different rooms?
Yes, definitely. Yeah. Definitely. We have our reference room we use for all the tuning, and this is a room that we know very, very well because we have spent so many hours in that room listening to different speakers and competitors and so on. So we know the room and we know how a good speaker should perform in that particular room. So when we are kind of satisfied in that particular room, then we start taking it in other rooms and see if it.
And again, do measurements in those rooms as well?
Sometimes. Not to develop the speaker as such, but more to
fine tune.
Yeah, to fine tune and see if something is if we can measure what we hear, for instance. If we sit there, discuss, there's something around whatever 3 kilohertz, then we can measure and check there is actually something there. Let's go find out what it is in the lab afterwards. And then at some point we also take the speakers home, bring them home in our familiar rooms, and see how they perform there.
I'm getting a sense that there is a lot of listening and a lot of reiteration in this process.
Definitely.
Yeah.
Definitely. And we always work as a team in the acoustics department there.
How long is a process like this?
From concept to finished product,
Yeah.
it's easy a year that goes by.
It's a long. It must be nice when it's finally done and you have a loudspeaker you can be proud of.
But the critical listening, where you actually build the filters and do all the iterations, is around a month. Then you have something that is almost there.
Almost there. Are you ready for a final question, Gustavo?
Yes.
It's from Rodolfo, and he wants to know what's the reason for making a closed cabinet instead of an open cabinet with bass reflex?
Yes. There's more reasons than one, actually.
Okay.
One of the reasons is that it's simple to do.
Okay.
There's less that you have to calculate and tune.
In the closed cabinet?
In the closed cabinet, yeah. The closed cabinet has a different low frequency roll-off than the open cabinet with the bass reflex. When you have an open cabinet, then you can tune this roll-off
Okay.
with using the bass or the port,
Yeah?
and you don't have this freedom in the closed cabinet.
Okay.
But instead, you have a very natural, it's called the 12 dB per octave roll-off, and it actually plays a little deeper than the ported one.
Okay.
But it sounds less deep because the slope of the roll-off is different. It's more shallow than the ported one.
Let me get it straight. If you have a closed box, it plays deeper, but it doesn't sound like it.
Yeah, and that's because when you have the port in,
Yeah.
if you imagine you have this is the roll-off
Yeah?
of the closed cabinet.
Yeah?
So it rolls off with 12 dB per octave.
Yeah?
Then if you have the bass reflex, you get like something that is
Okay.
it's more steep.
It's deeper, yeah?
It's deeper, but it doesn't go as low.
Okay.
Instead, it has like a hump, or you can tune it
Yeah?
with a hump around 80, 100 hertz, which gives it the impression of being
Okay.
boomy is not the right word, but you can get the impression that it plays more bass
Yeah.
and plays deeper than it actually does.
Okay.
When you have the closed box cabinet, one of the reasons that you would like to do this is that you use the air that is trapped inside the box
Yeah?
as a spring effect.
Okay.
So when the woofer moves in,
It gets more force from the pressure inside.
exactly,
the
it gets some
cabinet,
force from to move it out back again, which in the end can give you like a cleaner, more tight bass response than in the ported system.
yeah? So there's benefits to both ways.
There's
of doing
benefits
it?
to both ways, yeah.
Okay.
Exactly.
Christopher, thank you so much for being with us today.
You're so welcome.
It was a pleasure. And thank all of you for your questions.